Hello.
Hello. Okay, we are live. Welcome everyone to the 29 July 2020 Diagnostics Deep Dive meeting. Today we are going to be talking about, we will be continuing the best practices user journey deep dives. And the current topic is unexpected behavior user journey. But before we get started, is there any announcements anyone wants to make? Okay, so we can go right into the unexpected behavior document. Last time we brainstormed some of the use cases that fit unexpected behavior, as well as some of the toolings that can be used to tackle those use cases. Today we are going to be driving those use cases in a user journey manner. So we will be talking about, for each use case, we are going to be talking about how to understand that this is the use case that the user is seeing, and what are the steps that leads to the correct tool to investigate the use case. So to start, the first use case we have is result of a computation is bad or wrong. And this is basically when a function returns a wrong value, or for example, a request responses with the wrong payload or the wrong status code. So we can start with this use case, and then later we can move to the other ones. So how do we start investigating this use case? Or how we identify that the user is experiencing these issues?
So the most common scenario which I have seen, which fall into this category, is the fact that the JIT compiler misbehaves. So in which case we usually go by selectively, first we figure out which are the methods that get JIT compiled. Verbose option, compiler verbose option basically tells which methods are getting compiled at what optimization level. And then we look at the specific method or a group of methods which potentially would have taken part in the computation of the wrong result. And then we see if we can skip the compilation of that and see how the output is changing. And then if we confirm that, okay, one of these methods when getting JIT compiled at specific optimization level is causing this problem, then the next step would be to enable the compilation trace, optimization trace for that particular method. I don't know whether such an optimization trace exists for the compiler for V8, but ideally what I would expect is a incremental trace that happens that shows the transformation, incremental transformation between the bytecode and the final machine code.
Yeah, there
And
is.
then
You can turn on options to have it tell you when it's compiling a method. I'm not sure that it tells you like the different steps, but it at least will tell you, this method has been compiled.
I think V8 has at least one flag to show the bytecode generated. I don't think it has one to show the actual code generated. Like when V8 is still on the interpreters tab, you can see the bytecode, but once it's compiled down to machine code, I don't think there's any flags that can be used to look at that, although it can be still accessible via APIs. So it's a bit tricky, but both are possible. What we don't have, at least I don't think we have, is a mapping between bytecode and machine code. I don't think I've ever seen this too for V8. This would be similar to a source map, and I don't remember seeing it, although that doesn't mean it doesn't exist.
There are source maps, I think, for other reasons, like for the some of the flame graph stuff. I think end up using source maps, but I don't know. The first question I have is like, would people need to go beyond we see the bad behavior once this method is compiled?
I'd go one step back and ask, are JIT misbehave common issues? I'd expect the scenario to be more about developer errors in the function than on the V8 side.
I'm guessing it wouldn't be the most common. But I guess, Jarish, you've seen that be the case in the past a fair amount.
Yeah, I'm asking because that's not an issue that I came across before. I came across problems with V8 and performance and V8 and memory usage, but not misbehavior or the function being compiled just not reflecting JavaScript code. Those things I never seen. Again, that doesn't mean it didn't happen. That just means that it's not something that I experienced.
Yeah, usually this type of scenarios are very rare compared to the exceptions and crashes. But given the premise of this deep dive and documentation is to cover the user journeys which are possible, and given the fact that for this particular user journey, we should have at least laid out the plan for problem determination, even though it's a different matter whether the end user is able to follow that. Is interested to do the complete problem determination steps. But if we know the tools, if we know the methods, it's better we document that.
Yeah, I agree. I'm just thinking that when we're laying out the steps, checking for JIT compiler misbehavior might be the last step, since it's probably the most rare of the use cases. But I agree, we should list that, definitely.
Yeah, I'd agree. It could be sort of, if you've exhausted the other common, other problems we can come up with, then that one would be the one to look at.
I didn't catch everything you said about how to investigate this. So is there any steps before using the V8 tracers that user can can do to consider that this is happening?
So the compilation trace to figure out the participating methods, and
Can
then
you repeat?
compilation trace, JIT compilation trace. To output the list of all the methods.
Methods? Is it?
Methods, yeah. All the functions.
Okay.
Yeah, and then we need a means to figure basically skip the compilation of the faulty or suspected method.
There's a flag for V8 that we're running everything in interpreted mode. I don't remember it right now, but there is one. There's also one that forces everything to run as JIT code instead of interpreted. And that's probably also worth noting, similar to this one, but figure out skip the interpretation step, because V8 can misbehave on either way. It can either the interpreter can be interpreting the bytecode wrong, the bytecode can be wrong, or the generated machine code can be wrong. So there are three possibilities for V8 to misbehave when dealing with the generated code. So following these steps is possible to narrow down, on most cases, if it's misbehaving. Should we give more information here? For example, the flags that print out the bytecode for functions, or how to read the memory to check for the machine code? Or should we just advise users to open a ticket to V8 in that case?
That would kind of be my take, is that it takes a whole nother level to look at the bytecode and the machine code to figure out what's going on. But if you can basically take it down to this method's compiled, I end up with what I don't expect. If it's not compiled, I do end up with I expect. That should be enough to open an issue.
Mm-hmm.
About the V8, how we can see the bug is on the V8 or in the node.js?
If it is a compilation issue, so if it's a pure JavaScript function and the function logic doesn't match the result of the function, that's a V8 problem, because
No.
Node.js doesn't do any compilation of JavaScript, nor any transformation. It kind of does, but when requiring, we wrap it in a function, but that's the extent of it. Other than that, Node.js doesn't do any transformation on the code, and it definitely doesn't do any compilation. So if it's a compilation issue, it's definitely a V8 issue. It can be a Node.js issue when the user is calling APIs and the APIs are returning wrong values. But that should be covered in a scenario that is previous to this one, I think.
Okay.
In terms of investigation steps, at least. Personally, I usually first look at the user code to see the user/application code to see if the function has the logic outlined correctly. If it doesn't have, I look at library API calls to see if they are returning the expected value. If they are, I look at Node.js. If Node.js is returning correctly, I'd look at V8.
Yeah,
Basically
makes sense.
It's less likely to V8 to misbehave than Node.js, which is less likely than a library, which is less likely than an application code, at least in my experience. So I'm just writing down what I just said. Does anyone think of any other scenarios for computation misbehavior? Those are more symptoms than scenarios, but so can we start discussing how to identify incorrect logic on user code? And then once we cover that, if the user doesn't identify anything wrong, that means the next step can be the problem, and then the next one, and the next one. Does everyone agree with that?
Yeah.
Yeah, it makes sense that if you
Okay.
exclude your user code, you can then move into the library code, then to nodes. That order makes total sense to me.
So I usually start just by reading the function and seeing if there's any glaring issues in logic.
Or probably start with a live debugging and then look at the values of the variables at well-defined control flow points or the control code flow paths where we expect certain values and compare the live variables of those with expected values.
You said using the debugger, right?
Yeah. So assuming that the user code is a collection of my own written code and a set of calls to third-party library, and a set of calls to Node.js core APIs. So around these calls, I would have some values to pass to the APIs and some values to which I get from these APIs. So those are the control flow points where I would ideally check for correctness.
Does that capture what you said around API calls to libraries and Node.js at control points to check parameters and return values?
Yeah.
Yeah, I do that as well a lot. I usually start parenting functions because most of the time in the debugging code, it's not my code. I'm on a support team at Netflix, basically, for other teams. So I read more other codes than I write my own. This is just why I end up reading functions a lot instead of starting by adding breakpoints. But yeah, when I'm working on my own code bases, I usually start by adding control points via debugger or just console logs.
Yeah, and I guess whether you can attach the debugger or not kind of depends on, like, is this that you've run it yourself and you see the unexpected output, or it's running in production and you're trying to figure out what's going on?
Using debugger is not even possible in most cases on serverless environments, because it can be hard to run it locally, and when you deploy, you just can't attach the debugger. So in this case, console logs are a good alternative.
So it might be, we might say, if you can run the code locally, do that and use the debugger. Otherwise, in production, you're likely going to have to use traces, console logs, whatever, right? Like, in fact, if there's any trace you can turn on, that might be the easiest, versus like console logs, you need to change the code, right? And actually changing the code and redeploying is not necessarily that straightforward either. And kind of in that context as well, reviewing the code is probably the first step, which you can actually do without, that doesn't require access to production or doing anything. And so it's worth a first pass, like you said.
You also mentioned tracers in production. You have any?
Right, turning on tracing, right? Like if there's trace points built in to your application, or to your, or the runtime, turning those on can give you more information about the control flow, right?
The application trace points, yes. I don't think we have enough on Node.js and V8 for it to be useful in production, although I might be wrong.
There are a number of V8 ones. Now not sure that those would be the first set that would be helpful in figuring out an application issue though, so.
Yeah, I think they the V8 ones, they're like for optimization, the optimization GC runs, that kind of thing, and not for which functions are being executed. I think maybe you can use the inspector to attach to the inspector protocol, not the debugger, to attach to specific functions. So they run, for example, a console log every time they run. But I'm not entirely sure if that's actually possible. I never tried. And I don't remember which inspector domain is used. If it uses the debugger domain, it's not feasible for production because it disables a lot of optimizations on V8 and makes things like 2 times slower or more, depending on the situation. If it's the runtime domain, it's fine. Only the functions being traced will be affected. If it's debugger domain, it just doesn't work in production. I can't think of anything else to identify if the user code is correct or not. And I think those same steps apply to the other 2 use cases, actually.
Yeah. Just gets harder for you to, since it's code you haven't written, but you do generally have access to the source code, at least. I guess when you get down to Node, though, some of it might be in native code. Should make it harder.
Yeah, and even if it's on, if it's not on native code, if it's JavaScript, you can't change it to add console logs, for example.
Right.
I think you can use the debugger, but I'm not entirely sure. Since the files are embedded in the binary.
Right. Yeah.
I think the debugger works fine. You just can't attach console logs.
And I guess the key thing is trying to get a smaller recreate. Like we're talking about the 2, if you can run the code locally, you can investigate things. If you can't, then you're stuck trying to debug in live, which is hard. So it's kind of the first thing is, it's maybe obvious, but you got to narrow down the area of code where you think things are going wrong, or what kind of inputs cause it to happen, right?
Right.
In terms of
There-
Node.js APIs, I believe there could be two high-level classifications. One set are kind of idempotent or context insensitive, such as buffer, where it works with a piece of memory, and whether you call it in the context of a larger application or call it separately do not really make much difference. The second set of APIs are much more context sensitive, such as stream APIs. The lifecycle functions would actually be a function of other environmental factors in the process. So what that essentially means is the reproducibility is actually a function of the erroneous or the suspected API itself.
Mm-hmm. Yeah, and I'd imagine it's sorry. I imagine it's easier to come up with a reproducible for context-insensitive code than for context-sensitive, since usually you have all the context you need for this first one on the function, or it's at least traceable throughout the application. Whereas
Yeah.
the context-sensitive ones are a lot more event-based. Therefore, it's easy to miss when something changes, for example.
Makes sense.
Do you have any tips to find reproducibles? I always have trouble helping users when they have an issue but don't have an irreproducible. I always have trouble giving tips for them to write something.
I guess I would, and if you start with the main use case, it's like, how do you cut out portions of the code? You know, like you could buy, you know, maybe like bisection, that kind of thing. Like basically, if you can say it's cut the code in half and it still happens, and then cut it in half again, sort of work inwards towards the smallest piece where you still see the problem.
Yeah, that's a good strategy. It's a bit hard to do when the issue is only manifest in production, but that's a good strategy.
Yeah, the very first thing is to try and, even before that, is like, how do you make it reproducible, which comes to just what you said, right? Like if you have to wait for an hour for it to happen, it's much harder to debug than if you can figure out how to make it happen whenever you want, right? Yeah, definitely. If you can reproduce in your own instance, that's always the first thing to try for sure. Yeah, it's not just about, I wasn't just meaning about execution time. Like sometimes these things will be intermittent, right? Like in production, you may only
Right.
see it happen once every 3 hours or something. What you want to figure out is like, how do I make that happen once a minute or, right?
Right. We should probably give tips for the user on how to identify intermittent issues, even though there is no silver bullet to identify those. If there was, we wouldn't have flaky tests on our
Right.
builds.
Yep. Yeah. I mean, you probably know if it's intermittent in that, like, it happens occasionally, like it doesn't happen every time a particular piece of code runs. But like if you get an issue that happens once every couple hours, the first thing I'd want to do is figure out what code was running when that happened. If I have, 20, 30 different requests that can come in, is there a correlation to the request that came in, right?
Mm-hmm.
And then it's like, can you figure out what parameters there were when and is there any consistency? I know there was one we spent a long time looking at, and it turned out to be related to the SQL, the length of the SQL query. When it was exactly X characters, it triggered the bug that was causing us grief. So like looking at those, if we can narrow it down to like, yeah, okay, I was running this particular request, and here are my parameters, even just looking at the parameters for a number of different failed ones and seeing if there's any correlation between them can help you try and recreate it or understand what's going on. Right, like compare between the failed paths to see if there's any commonality in the failed ones.
Mm-hmm. Yeah, I think those are good tips for narrowing down intermittent issues and making them more consistent.
Yeah.
I think maybe compare with hardware metrics, and each request can be great.
You said header metrics, right?
Yeah.
Mm-hmm.
By header metrics, you mean the headers that were passed into the request or something else?
Really, I say hardware, not header.
Hardware, right, okay.
Yes.
Oh.
Like IO operations, how much your code is running at the user space or like that. I don't know if it makes sense to a easy reproducible, but can be good.
It can be, for example, sometimes you're running on, I don't know, AWS maybe, and the underlying hardware might be slightly different, but just enough to make things go south. It's a good thing to compare. I wouldn't start there, but I wouldn't discard the possibility.
Yeah.
We definitely saw similar issues in Netflix, I think.
Yeah, it might be, it's like you're working through the list of what's the same and what's different and looking at passing and failing cases to try and see if there's any hints for things that were influencing that output.
Yeah, I think the more overall idea is comparing our environments and seeing if there's a difference that can be leading to the intermittent issue. So it could be, for example, dependencies. Some version might be different from other services. Not only npm dependencies, but packages installed on a operating system level. The kernel might be slightly different. The hardware, the CPU might be on a different version. So comparing hardware metrics and overall environment specifications.
Some libs have a binding to a C application, so maybe compare the hardware. It's great.
Yeah, if it's binding to a different version of a C library, it can cause a lot of pain, a lot of silence pain without any errors, but giving wrong results. All right, anyone has any other suggestions for intermittent issues? Okay, I think we can move to...
My only thought was like in all of this, is there anything like some of this is fairly general. Is there anything more node specific that we should be calling out in terms of like how to do any of this stuff?
I think there's a question on how do we look for parameters? Like how can I have an application running. How can I collect the parameters that are being passed to a specific function? Do I need to restart my application with some library loaded that will gather the information? Is there something that I can start at runtime? Is there some flag on Node.js that I can use?
Right, or in that case, I was thinking of like if you've got web requests coming in, you can look at the differences in, you know, what the parameters that were requested in the say the API, the REST request or something like that. But it is a pretty broad, like there's a lot of different levels that this could be done at, right?
Right. Yeah, I don't have a good answer for that. I never done this in Node.js. I have only done that on C and C++ code using BPF trace.
Right.
So maybe it's possible to use the inspector with the same approach, but I'm not sure. Well, there's nothing Node.js specific on comparing parameters once we gather them. At least I don't think so.
No.
Also for hardware and environment specifics, there shouldn't be any specifics for Node.js. Besides look if dependencies, look if dependencies are the same.
Actually, although is this the one where we mentioned before, like, you know, the first thing you should do is if you have a pass, if it's like newly introduced, you should look at like node versions, library versions, all that kind of like what changed between the two cases is, Or was that a different use case?
We classified it as a different use case, but we also mentioned that it could be an initial question. So I think
Right.
it's a good one. If new error check for changes in version.
And actually even upgrades to your app, like, because that, you know, you can then go and look at the deltas between those to see if anything's related. Because actually that's the very first, like I know somebody reported recently a change in the Intel behavior, and it's like, it was like, hey, after upgrading
Yes.
to this version, it was like, okay, then we could look at the change log, and then from the change log, we could say, okay, yeah, you know, we did make a change to ICU, and then it was like, oh, but that was planned. And so that's actually a good starting point if that's possible.
I agree. That's a good starting point. Just going back here quickly on the checking the environment specifications. Although this could probably fall under there as well. But if dependencies are the same version,
Yep.
there is another scenario that could happen, which is less likely but not impossible, where you download the same package, the same version, but the code is different, either because someone forced to push it to NPM, or because it's being installed from GitHub, which is not recommended, or worse, if there's a man-in-the-middle attack. So there are some scenarios where you can download the same version of the NPM package, but receive different code, and that can cause unexpected behavior. Do you think you have enough for the identifying and helping report issues on the Node.js API? We can review what we have.
Yeah.
This might be a good idea. So for starters, if the error started recently, look for changes in Node.js version dependencies or any changes to the app. If that's not the issue, but still the function narrows down to an issue on a Node.js API, it's a good idea to create a small reproducible, in which case context insensitive APIs such as buffers should be easy to reproduce, and other context sensitive APIs might be harder. And for those, we have some tips on how to make the reproduce smaller. Starting by trying to run the code locally, so you don't have to rely on adding console logs to production, and you can use more tools like the debugger. If the execution time is long, try to make it smaller. We didn't give any tips on this one. Maybe we should. Another possibility is that the issue is intermittent. in which case we have some tips such as figuring out if other code is running simultaneously, or at least as simultaneous as some code can run in Node.js. Compare parameters, both in a higher level, looking at HTTP parameters, or at a function level, if you can capture that. Compare those parameters and also compare the environment specifications to make sure there is nothing in the environment that might be causing the issue. Once the execution time is as low as you can get and you get the issue to happen as frequently as you can get, preferably all the time, use the steps we listed in the first example to narrow down the code and create the smallest possible reproducible. And for that, the user can cut everything from the first point where the issue is identified, which is usually an Node.js API call. And then before that code, the user can apply a bisecting strategy to identify which parts of the code impact the results of the API call. After bisecting everything, the user should have the minimal reproducible, and then they can open a issue on Node.js. And this is mostly a note about debugging Node.js applications. In case. I think we covered a lot, except for reducing execution time.
Yeah, I don't know that you reduce the execution time except by reducing what you run to you're cutting it down to like, okay, a smaller subset reproduces the issue, right?
Right. I think it's worth noting from DevTools profiler will show execution time for each line of the application based on the sampling that it performed, which can also be used to identify which lines are taking longer and reducing the time that the application spends there. Okay, we have 1 minute left. I think we have a good start on this user journey.
Yep.
Yeah.
We can continue next in 2 weeks, discussing library code and how to identify and best practice to report library code issues.
Sounds good.
All right.
Okay. Talk to everybody later.
Have a good one, everyone.
Thanks. Bye.
Right.
Thanks. Bye.